My name is Flash Isaac, and I'm a teacher from the future. When I was much younger, I saw thousands and thousands of people fail Jamb and unable to gain admission. This made me travel in time. Now I am back with a Flashlearners Jamb app and a series on YouTube tagged 120 Days to Jamb. My mission is to help you blast Jamb and as well get justice for everyone who Jamb has served breakfast. This is episode number 34 of the 120 Days to Jamb Mathematics with Flash Isaac. In this episode, we shall start answering questions under polynomials. All these topics generally. And in the next episode, we shall conclude polynomials, still questions and answers session. We are taking the questions from the Flashlearners Jamb application. Do well to install one for yourself and begin to enjoy. The first question we have here says, find the remainder when s cubed minus 2s squared plus 3s minus 3 is divided by s squared plus 1. In this case, we are dealing with division of polynomial. When you divide a polynomial, you get the quotient and you get a remainder. The divisor here is a quadratic polynomial. As such, the easiest thing for us to do is long division. If it were a linear polynomial, it will be easy for us. We will use substitution of polynomials. We shall see that also shortly. In this case, you have something like this. The polynomial will be here, s raised to the power of 3 minus 2s squared plus 3s minus 3. Then the divisor will be here, s squared plus 1. Now, in division of polynomials, you take the first one here and you take the first one here. You divide them. S raised to the power of 3 divided by s raised to the power of 2. That will be s. So you put that here as quotient. Then you use the quotient to multiply the divisor to give you s times s squared is s raised to the power of 3. S times plus 1, that is plus s. After this, you subtract minus here. To subtract polynomials, they must be in the same degree. This is of degree 3 and this is of degree 1. This polynomial does not have degree 2. So you can't say 2s squared minus s. No. Instead, this s should go here. Meaning, here will be plus s. Nothing here. Or you can just say plus 0s squared, which is the same thing as 0. Or you can leave it like this. But while subtracting, know that it is 3s and s that can be subtracted because they are the same degree. There is no s squared component in this polynomial. If you understand that, here becomes nothing here. Here is 0 as a constant. Minus 3. 3s minus s. That is plus 2s. Nothing here. So minus 2s squared remains. And minus 2s squared minus 0 minus 2s squared. S cubed minus s cubed. Here is 0. So this is what we have right now. This is the procedure. The next step is to continue the same thing. Now that we've gotten this answer and the degree is still higher or equal to what we have as the divisor, we do the same thing. We pick this first one and this first one. Minus 2s squared divided by s squared. That will be minus 2 remaining. So here is minus 2. We use our new divisor. No, we use our new quotient to multiply the divisor. Minus 2 times s squared. That is obviously minus 2s squared. Minus 2 times plus 1. That is minus 2. Minus 2. The next thing, subtract. You do like this. You put minus here. Here is constant and here is constant. So minus 3 minus 2. Minus 3 minus minus 2. This is minus 3. Minus minus is plus 2. Minus 3, you are owing 3. Plus 2, you paid 2. You will still be owing 1. So here remains minus 1. So we have minus 1 here. Here is 2s. We don't have any s component. There is no degree 1 in the under polynomial. So 2s minus 0. 2s remains 2s plus 2s. Now here is of degree 2. Here is of degree 2. We can subtract. Minus 2s squared minus 2s squared. That will be the same thing as minus 2s squared plus 2s squared. It goes to 0. Now what do we have? We have a remainder that the degree is lower than the degree in divisor. Anytime you arrive at a point where the degree of your answer is lower than the degree of your divisor, here will be your remainder. Now if you were asked for the quotient, here would be your quotient. And here is the divisor. Here is the dividend, or you say the polynomial. 2s minus 1 is the remainder, and option A is the correct option. S plus 1 is a factor of the polynomial. H of s is equals s cubed plus 7s minus k. S plus 1 is a factor of this polynomial. What is a factor? If I say 2 is a factor of 4, it simply means that 4 divided by 2 will give you exactly 0. So, if s plus 1 is a factor of this polynomial, it implies that if you substitute the value of s in this polynomial, you will get 0. What is the value of s? Here is s plus 1. The value of s will be equating the divisor to 0. If you equate s plus 1 to 0, s will simply be 0 minus 1, and s is equals minus 1. This is the value of s. So, s plus 1 being a factor means that s equals minus 1 is a factor. And when you substitute s equals minus 1 into this polynomial, your answer will be 0. That is what we call factor. So what does that imply? It implies that h of minus 1, because s is minus 1, h of minus 1 is equals, here is minus 1 raised to the power of 3 plus 7 times minus 1. Anywhere you see s, you put minus 1 minus k. Now what is it equal to? 0. That is factor. Since this is a factor, if you substitute the value of this into the polynomial, you will get 0. Which means here and here are enough for us to get the value of k. Minus 1 raised to the power of 3. If I am not so wrong, this will give us minus 1. Minus 1 raised to the power of 2 is 1. Then raised to the power of minus 1 again, that is minus 1. Or in other words, minus 1 cubed is minus 1 times minus 1 times minus 1. Minus 1 times minus 1 is plus 1. Plus 1 times minus 1 is minus 1. Plus 7 times minus 1, that is minus 7, minus k is equals 0. Minus 1 minus 7, that is minus 8, minus k is equals 0. Take collecting like terms, minus k will be 0 plus 8. Because as minus 8 moves to the other side, it becomes plus 8. Therefore, minus k is equals 8. We are not looking for the value of minus k. We are looking for the value of k. To get that, we divide both sides by minus. Here minus 1, here minus 1. So k becomes minus 8. The value of k is minus 8 and not 8. That is it, ladies and gentlemen. For the next question, find the remainder when this polynomial is divided by s plus 3. Find the remainder when this polynomial is divided by s plus 3. Remember what I told you earlier. Anytime you are given a linear polynomial as the divisor, what you simply do is, instead of long division, you equate the divisor to 0. You simply say s plus 3 is equals 0. As such, s is equals minus 3. Then put the value of s equals minus 3 into this polynomial. That will be 2 minus 3 raised to the power of 3 minus 11 minus 3 squared plus 8 minus 3 minus 1. That will give you minus 178. Ladies and gentlemen, the remainder when this polynomial is divided by s plus 3 is minus 178. Simply equate the divisor to 0. Get the value of s, put the value of s into the polynomial. Your answer will be the remainder. A polynomial in s whose zeros are minus 2, minus 1, and 3 is dash. This polynomial is obviously of degree 3 because it has 3 roots, or 3 answers, or 3 zeros. When you remember in quadratic equation or quadratic polynomial, I said that when you are given the roots, the zeros, or the factors to find the quadratic equation, you simply say that s squared minus sum of roots times s plus product of roots is equals 0. How about for cubic polynomials? For cubic polynomials, if you are given the zeros or the roots, you simply say that s minus alpha times s minus beta times s minus gamma is equals 0. In this case, we are given the zeros minus 2, minus 1, and 3. So these zeros are alpha, beta, and gamma respectively. We substitute to have s minus alpha, that is minus 2, s minus beta minus 1, s minus gamma 3 is equals 0. In mathematics, one skill you must learn is understanding signs. Signs alone can make you fail up to 80% of the questions, even when you know how to solve them. For example, we are given the zeros minus 2, minus 1, and 3. Some persons will just say s minus 2, forgetting the fact that there's already minus here and there is minus here. So take note of that. This gives us s minus times minus 2, that is plus 2. S minus times minus 1, that is plus 1. S minus times 3, that is minus 3, is equal to 0. Here is where the question comes in. How do we multiply these polynomials? Under multiplication of polynomials, I did not answer multiplication of 3 brackets because I know we will certainly see it in this question. Remember, this is a series. Doesn't mean that one episode will cover everything. No. At the end of all the episodes, or at the end of the series, everything will surely be covered. So it is a complete video. The 120 videos work together. It is when you are done with the 120 videos and you see certain things are missing that you have the right to complain. When you have 3 of these, remember I told you that for multiplication of polynomials, you distribute one over the others. This is how to answer things like this. You pick out these first 2. You distribute one over the other. So you take the first s, distribute it over s plus 1. Then take minus plus 2, distribute it over s plus 1. Which is the same thing of saying, use this to multiply this, and use this to multiply this and this. Then do this first before you add this. That should give you s squared plus s plus 2s plus 2. This is this, and s minus 3 is equals 0. From here, to use this to multiply this, use this smaller one to multiply everything here, which is distribute this over all these guys. How do you do that? The first is s, so take s, distribute it over this, s squared plus s plus 2s plus 2. Then you take the set minus 3, you distribute it over here, over s squared plus s plus 2s plus 2. Doing this, you will get s times s squared is s root to the power of 3 plus s squared plus s times 2s, 2s squared plus s times 2, 2s minus 3 times s squared, rather, that is minus 3s squared, minus 3 times s, that is minus 3s, minus 3 times plus 2s, that is minus 6s, minus 3 times plus 2, that is minus 6. From here, let's arrange them based on their degrees. This is s root to the power of 3 plus s squared. This is another s squared plus 2s squared. This is another s squared minus 3s squared. Then we move to s plus 2s minus 3s minus 6s minus 6. Everything equates to 0 actually. So this is s raised to the power of 3, s squared plus 2s squared, that is 3s squared. 3s squared minus 3s squared, that is 0. So 0s squared. 2s minus 3s, that is minus s. Minus s minus 6s, that is minus 7s. Then minus 6 remains equals 0. So that is basically your answer. S raised to the power of 3 minus 7s minus 6. I am slow because I am explaining to you. In the exam hall, as you write, it will be faster. Don't panic about time. If you know what you are doing, even if you solve everything step by step, you will certainly finish. It is by the time you start thinking, how do I answer this? How do I solve this? And you start making mistakes. That's the only time you see that time will be so far spent. In this question, we are asked to make G subject formula. G. To make G subject formula, G is here. We need to start removing distractions, the things that would affect G, so that G gets clearer and clearer. You see that everything here, they are joined by multiplication. 2 times pi times root L over G. When things are gone by multiplication, you cannot pick one to the other side like that. No. You can't collect like terms like that. No. What we can do is divide. It's only division that can separate what multiplication is marrying. So let's begin with dividing by 2 pi and dividing here by 2 pi. 2 pi divided by 2 pi is 1. This equation becomes t over 2 pi is equals root L over G. Now, what is covering this G? Square root is among the things covering it. And I told you, to remove square root, you square both sides. To remove cube root, this is cube root, you look for the cube of both sides. Everything here raised to the power of 3, and everything here raised to the power of 3. To remove fourth root, if here is 4, you look for everything here raised to the power of 4, everything here raised to the power of 4. So 4 raised to the power of 4, we cancel fourth root. Now, if you are given something like this, t raised to the power of 4 is equals 2 pi, and you are asked to make t subject formula. Since t is raised to the power of 4, to remove this power, you look for the fourth root of both sides. That is here fourth root, here fourth root, so that t becomes the fourth root of 2 pi. If here is raised to the power of 6, to remove that, you look for sixth root. So that is basically it under change of subject formula. Once you understand all these keys, no matter how the question comes, you should not have problem. to whom much is given, much is expected. So here is squared, here squared. That leaves us with t over 2 pi squared is equals L over G, because this square has removed the square root. We are making G subject formula. So what do? If you cross multiply G times t over 2 pi squared is equals L. To get G only, and multiplication is covering these two or is holding them, you divide both sides by this guy. So if you divide here by t over 2 pi squared and you divide here by t over 2 pi squared, this will cancel this. So G becomes L divided by t over 2 pi squared. This is the answer. But let's see the way the options are coming. From the option, what they did is they opened up the bracket. If we have G to be equals L over t over 2 pi squared, this is the same thing as L over t raised to the power of 2 is t squared. Pi, 2 pi raised to the power of 2. 2 raised to the power of 2 is 4. Pi raised to the power of 2 is pi squared. So here will be 4 pi squared. So L over t squared over 4 pi squared. They simplified further. This is what they did. G becomes L divided by t squared over 4 pi squared. L divided by t squared over 4 pi squared. If you change this division to multiplication, this other part of the expression inverts. So G is equals L times 4 pi squared over t squared. And that will give you G is equals 4 pi squared L over t squared. 4 pi squared L over t squared, as seen in option B. Long but very, very easy. Nothing is complicated in all this. Ladies and gentlemen, this brings us to the end of this episode. I hope you found it helpful. See you in the next episode. And don't forget to get the Flashlearners Jamb app and start practicing the mobile version, the desktop version. Visit flashlearners.com or reach me directly for inquiries. And if you have any questions for the app or as you practice, just screenshot and send to me. I will attend to it. See ya.